Welcome to trigonometric equations involving auxiliary angles. So when we convert a function in the form of a sine x plus b cos x, we're going to convert it into one of the compound angles. So we're going to learn different ways to do this. So what we're going to look at is converting a sine x plus b cos x into r sine, potentially even r cos x plus some value of alpha. So r sine x plus alpha, when we use our compound angles, we get r sine x cos alpha plus r cos x sine alpha. And we want to equate a sine x plus b cos x in that form. So you'll notice that the coefficient of sine x on the left-hand side is a, and the coefficient of sine x on the right-hand side is r cos alpha. So r cos alpha is equal to a, and for the blue part, the coefficient of cos x is b, and the coefficient of cos x is r sine alpha. So r sine alpha is equal to b. So this is how we go about doing it as a proof. So if we square the first and the second equation, you'll notice you get r squared cos squared alpha plus r squared sine squared alpha. So if you add them together, that equals to a squared plus b squared. And the left-hand side, if you take r squared out, inside the brackets, you would get sine squared alpha plus cos squared alpha, which is 1. So therefore, r squared is equal to a squared plus b squared. So r is equal to the square root of a squared plus b squared. So that is something you can learn, but it's better that we actually prove it all the time. And similarly, when we divide the second equation by the first equation, we get r sine alpha over r cos alpha, and sine over cos is tan, and it's b over a. So therefore, alpha is equal to shift tan of b over a. Now this will happen every single occasion, but as I said, it is better that we actually write it out as a proof as shown, and HSC working and marking guidelines are showing that you should set out your proof as we have done. So that's what we sort of just talked about. That's the summary. And these used to be rules that we used to just learn off by heart. And this is what we will get to with our proofs. But we'll go through each one just as a setting up the proof using our compound angles. So here's our first one. We've got surd 3 sine x minus 3 cos x, and we're going to write it in the form of r sine x plus alpha. So we're going to start with the r sine x plus alpha, and we're going to expand that as a compound angle. So r sine x plus alpha becomes r sine x cos alpha plus r cos x sine alpha. So if you equate your terms, then the coefficient of sine x is surd 3, and the coefficient of sine x is r cos alpha, and the coefficient of cos x is minus 3, and the coefficient of cos x is r sine alpha. So that allows us then to do exactly what we did before. So we're going to square them and add them, and we're going to divide them. So square both sides, and you get r squared equals 12. So r equals the square root of 12. And dividing both sides, the second equation by the first, you get tan alpha equals minus 3 on surd 3. So alpha is equal to minus pi on 3. So therefore, surd 3 sine x minus 3 cos x can be written as surd 12 sine x minus pi on 3. So here's our second example where we're actually going to use it and solve. So once again, we're going to do, it's almost the same as the last one, but instead of being a minus, it's a plus. Surd 3 sine x plus 3 cos x. We're going to express it in the form of a sine x plus alpha, and then we're going to solve. So equating our terms, a cos alpha equals surd 3 and a sine alpha equals 3. Oh, sorry, we should have expanded, done the compound angle form. Squaring both sides, you get a equals square root of 12 again. Dividing this second equation by the first, you get tan alpha equals 3 over surd 3, and alpha equals pi on 3. So therefore, surd 3 sine x plus 3 cos x, written in the form of a sine x plus alpha, is surd 12 sine x plus pi on 3. So if we replace that into the equation, then surd 12 sine x plus pi on 3 is equal to surd 3. So if you divide both sides by surd 12, you get sine x plus pi on 3 equals a half. Shift sign that half and use it in the A and S quadrant. And so you get x plus pi on 3 equals pi on 6, 5 pi on 6, and 13 pi on 6. The first one, pi on 6, when you minus pi on 3, you get a negative. So obviously that is not in our domain from 0 to 2 pi. 5 pi on 6 minus pi on 3 is pi on 2. And 13 pi on 6, which is the next value in the next rotation. When you minus pi on 3, you get 11 pi on 6. Thank you.